So far, we've talked about what a database is, what a database server is. Well, in this nugget, we're going to cover all of those objects inside of a database. We're talking about tables, views, indexes, and stored procedures. Let's do it. Let's begin with the most common and most important object in a database. That would be the table object. A table is used to store data. And here's an example of a table right here. It's very much like an Excel spreadsheet. We have rows, otherwise known as records, that describe the entity that we're storing. We also have columns. Columns define the kind of data that fits inside of it, as well as the type of data, otherwise known as the data type. So for person ID, for example, we're storing integer values, numeric values. For the name column, we're storing character values. And by the way, the name of this table is characters. And that's because we're storing Star Wars characters within them, so that describes all the entities, all the records, all the data within this table. We also have the concept of a primary key. Now, a primary key is used to help the database engine uniquely identify the rows within this table. So, for example, if we had 2 Luke Skywalkers but we didn't have a person ID, how would the database engine know which record to retrieve if someone were to query this table for Luke Skywalker? It wouldn't. So that's what a primary key is used for, just simply to uniquely identify the records within this table. The combination of all of these columns for that record makes it unique with the primary key. Database engines support auto-numbering primary keys, which is what we have here. If we were to add a record, we wouldn't have to worry about this column at all. It would automatically fill in with the next available ID and provide that ID for that record. We also have the concept of a foreign key. Now, in order to show this, I needed to bring another table in view here. So I brought in our planets table. Can you guess what the primary key of this planets table is? Yeah, you guessed it. It's the planet ID right here, otherwise known as the PK. Now, notice something interesting. Our original characters table here has a home planet ID column. Notice that their data types match. This is what's known as the foreign key in this table because it references a primary key in another table. And the whole purpose of this is to set up a relationship, a linkage between these two tables. That does a couple of things. Number one, it enforces data integrity. It ensures that we cannot put any characters in this characters table without having a valid planet. So if you look here, Luke Skywalker has planet ID 1. Look at down here, planet ID 1. Yeah, Luke's from Tatooine. Look at Leia here, planet ID 2. Planet ID 2. Leia is from Alderaan. So a foreign key is a column in one table that references a primary key in another table. And again, it's used to set up relationships between data in multiple tables and to enforce referential integrity. This also enables us to write queries using the SQL join statement, more on that in a future nugget, that will allow us to pull back a single view containing columns from multiple related tables. This is something that we commonly do with views. For example, let's say that we needed to write a query to pull back our character name, their gender, the planet name, and the population of that planet. We can write a view containing a query that would give us all of that information. Views are primarily used for 2 purposes. Number 1, security. They act as a data access layer, so we give users, developers, and applications the ability to access the data within these tables without actually giving them access to the tables themselves. The only folks that should have access to these tables are the select few that manage and build them. And number 2, to simplify the structure and the output of these tables. A view allows us to filter out specific columns and records. That way we can give users, developers, and applications only what they need to see, because oftentimes these tables will contain hundreds of columns and millions of rows. So we can abstract what they see through views. Another important database object is an index. Now, indexes in the world of databases work just like they do in books. For example, let's say that you have a technical book and you want to find a topic. Would you go page by page through that book looking for that topic? Or would you go to the index, which will show you which page it's on, and then go directly to that page? Exactly. Same exact thing in databases. We place indexes on columns, the most popularly searched columns in a table, and that will allow the database engine to quickly and efficiently retrieve that data when a query hits it. The last database object we're going to look at here is a stored procedure. Now, a stored procedure is similar to a view in that it's just simply a container for SQL code. It allows us to easily re-execute that code by calling the stored procedure. but it's a lot more powerful because we can parameterize it. We can define parameters and then pass in different parameter values every time we execute it to potentially get different results. So I like to think of stored procedures as mini executable programs within your database. Let me show you how some of this stuff works. Here we are in SQL Server Management Studio. We have a connection to our database server, and on the server, we have SWDB. This is our Star Wars database. If we were to expand tables, here's all the tables within. Here's that characters table, which I actually called people here, and here's that planets table. We could expand this to see all the columns as well as their data types. We can see that person ID is the primary key, and we can also see the same thing here for our planets table. We can see planet ID is the primary key. Now, one thing I want to show you here is how to create a view. I'm going to make a brand new view here, and what we're going to do is write a query, not actually write it, we'll have it written for us. We'll use the designer here to write a query that pulls back columns from both of those tables. So let's grab people and planets. So we'll add both of those tables into our view. We'll close out of this, and now we've got that linkage set up here between home planet ID and planet ID, and I'll make that link right here just by dragging it. There we go, and that'll automatically write that SQL join statement for us. So let's say we wanted to pull back the name of our person, the gender, as well as how about the name of the planet and the population. Now notice, because we have the same name of the column here in both of these tables for name, it added what's known as an alias down here. And I'm just going to rename this as from expression 1 here to planet name. We now have a view, so I can save this view. I'll call this view people planets. Planets. Now we have a view in place, and we can actually see this view down here. We can right click on it and choose to execute it. This will execute that SQL statement, and there it is. It's a view containing columns from both of those tables. Another thing I want to show you here is that we have an index on this people table, so when we perform searches against that name column, they're extremely fast. So if we come down here to indexes, check it out. There's an index on that name column. I can actually open this up here, and we can see that this is placed directly on that name column. Let me also show you what a stored procedure looks like. Here I created a really simple stored procedure called getSWCharacters. Here this accepts a parameter called name, and this is the data type of that parameter. So any data that's passed in must adhere to this type of data, which is just character data in this case. Here we have a block of SQL contained within this stored procedure that is pretty much the exact same SQL that we just used inside of that view. It's going to pull back a couple of columns here, name and gender from the people table, and a couple of columns from the planets table. And notice we're joining together on that common column. Primary key in the planets table and the foreign key here in that people table. And we have what's called a where clause on here to filter out, to only return any records that contain whatever is passed in as that parameter. So I'm going to go ahead and create this stored procedure, and that will then allow us to execute it as much as we'd like, passing in different parameter values each time. So if we were to execute this with LU, this will return any people in this case, or characters, that have LU inside of their name. So notice here Luke and Luminara. We could execute it again with a different value here. How about LA? And this should return all kinds. We've got a lot of records in here, a lot of characters that have LA in their name. So there's Owen Lars. There's another one. There's another one. All the way down, you can see all of these characters have LA in their name. So that's a stored procedure, a nice little mini executable program within our database. In this CBT Nugget, we covered essential database terms and concepts, and even saw these database objects in action. I hope this has been informative for you, and I'd like to thank you for viewing.